Titrations are a fundamental analytical technique in chemistry, used to determine the concentration of an unknown solution by reacting it with a solution of known concentration. The process involves the gradual addition of one solution, the titrant, to a known volume of another solution, the analyte, until the reaction between the two is complete. The point at which the reaction is complete is known as the equivalence point, and it is typically indicated by a color change or some other observable signal. Titrations are used to find out concentrations because they allow for precise and controlled addition of the titrant to the analyte. By carefully measuring the volume of the titrant required to reach the equivalence point, chemists can calculate the concentration of the unknown solution using the known concentration of the titrant and the balanced chemical equation for the reaction. This is done by applying the stoichiometric relationship between the titrant and the analyte, which tells us how many moles of one react with the other. For example, in an acid-base titration, the titrant could be a strong base, such as sodium hydroxide, NaOH, and the analyte could be an acid, like hydrochloric acid, HCl. The reaction between them is shown in the formula on the screen. By knowing the volume and concentration of NaOH used to reach the equivalence point, the concentration of HCl in the analyte can be determined. The reason titrations are so valuable is their precision. They are used in various fields, from pharmaceuticals, where accurate concentrations of active ingredients are crucial, to environmental chemistry, where determining the concentration of pollutants in water is essential. Titrations provide a reliable method to obtain quantitative data that is critical for making informed decisions in research, manufacturing, and quality control. In titrations, single indicators are commonly used to detect the equivalence point because they provide a sharp and distinct color change at a specific pH or point in the titration process. An indicator is a substance that changes color in response to changes in pH or the concentration of a specific ion. The choice of indicator depends on the type of titration and the expected pH at the equivalence point. For example, in an acid-base titration where a strong acid is titrated with a strong base, phenolphthalein is often used as an indicator. Phenolphthalein is colorless in acidic solutions but turns pink in basic solutions, changing color around the pH of 8.2 to 10, which is close to the equivalence point of this type of titration. Using a single indicator is important because it ensures that the endpoint, the point at which the indicator changes color, closely matches the equivalence point of the reaction. If the wrong indicator is chosen, the color change might occur too early or too late, leading to inaccurate results. For instance, methyl orange is used for titrations involving a strong acid and a weak base because it changes color at a lower pH, which is more suitable for the expected equivalence point of such reactions. In summary, titrations are an essential method in chemistry for determining the concentration of unknown solutions. They rely on the careful addition of a titrant to an analyte until the reaction is complete, with the equivalence point typically indicated by a color change from a single indicator. The accuracy of titrations depends on the appropriate selection of the indicator, which ensures that the observed endpoint accurately reflects the completion of the reaction, allowing for precise and reliable determination of concentrations.